Have you ever watched a hummingbird zip around a flower? It moves so fast and can hover in one spot. Now imagine building a robot that does the same thing, only smaller, as tiny as a mosquito. This isn't science fiction anymore. Scientists are building micro-drones, tiny flying robots that could change everything. These machines can go places humans and big machines can't. A normal drone is about the size of a dinner plate, but a bug-sized drone? That's a game changer. It could slip through a window unnoticed, explore disaster sites, or even pollinate plants. The possibilities are endless. What makes these drones special is their near invisibility and agility. Scientists call this bio-inspiration, copying nature's designs to solve engineering problems. By mimicking insects and birds, engineers are creating machines that are more efficient and agile than ever before. We're just at the start of this technological adventure. Get ready to shrink down with us as we explore the world of micro-robotics. We'll look at how these tiny flyers are made, what they can do, and a new Chinese drone making headlines. We'll compare it to others around the globe and imagine a future filled with tiny robots helping us in ways we can barely imagine. The future of technology isn't just about bigger and faster. It's about smaller, smarter, and quieter. And it's happening right now. These little robots are a huge deal. They blend into the world around them, almost invisible. Nature has had millions of years to perfect flight. Now, we're learning from the best. So, let's dive in. The age of micro-drones has begun. Scientists are closely studying how nature designs things like insect wings. By copying the structure of a dragonfly's wing, they create robotic wings that are strong and lightweight. These bio-inspired designs let micro-drones move with agility and efficiency that traditional machines can't match. Nature's blueprints are shaping the future of robotics. We're only beginning to understand what's possible. Let's zoom in on one of the most exciting micro-drones, China's mosquito drone. Developed at Beihang University by Professor Song Baifeng's team, this tiny robot moves like a real insect. Instead of spinning rotors, it has two delicate wings that flap rapidly, giving it lift and control. The drone weighs about as much as a paperclip and is made from ultra-light materials. Inside, tiny motors and electronics control the wing flapping, allowing it to hover, dart, and turn like a real bug. The wings are powered by a piezoelectric actuator, a special motor that bends when electricity is applied, making the wings flap. This method is efficient and allows for precise flight control. The drone can even carry a tiny camera or sensor, making it a powerful tool for gathering information. Getting a machine this small to fly stably is a huge challenge. Air currents that barely affect larger drones can toss a micro-drone around. Professor Song's team developed advanced control systems to help the drone adjust in real time. The results smooth, agile flight in a package smaller than your thumb. This is a major leap forward in micro-robotics. The mosquito drone's design is clever, efficient, and bio-inspired. It's a beautiful example of technology learning from nature. This tiny flyer is making headlines for good reason. It's not just small, it's smart, and it's changing what we thought was possible. One reason micro-drones are getting so much attention is their military potential. Imagine a soldier needing to scout a building. Sending a person is risky, and a big drone is too obvious. But a swarm of mosquito drones? Nearly invisible and almost silent, they can slip in undetected. Their flapping wings make only a faint buzz, blending in with real insects. They're hard to see, hard to hear, and even radar struggles to spot them. These drones can gather intelligence up close, mapping out enemy positions or detecting hazards. Swarms could work together, each carrying different sensors, cameras, microphones, or chemical detectors. Together, they create a detailed picture of the battlefield, helping soldiers avoid danger. This technology could transform military strategy, shifting from big, expensive machines to swarms of smart, cheap, hard-to-stop robots. The mosquito drone is a perfect example of this new era. For military planners, developing and defending against these tiny spies is now a top priority. The silent spy in the sky is no longer science fiction. It's here, and it's changing the rules. The future of warfare is getting smaller, smarter, and stealthier. Micro-drones are leading the way. The game has changed. China's mosquito drone is impressive, but the global race is on. The US has the Black Hornet Nano, a finger-sized helicopter drone already used by the military. Developed in Norway, the Black Hornet sends back live video and thermal images, but uses rotors, making it a bit noisier than flapping wing drones. The challenge for the US and its allies is to keep up with China's bio-inspired designs. At Harvard, researchers are working on the RoboBee, smaller than the mosquito drone, but still facing power challenges. Each country is racing to solve problems: tiny batteries, smarter control systems, and mass production. The first to crack these will have a big advantage, not just in the military, but in all the amazing things these drones can do. This global competition is pushing technology forward at lightning speed. The race is on, and the world is watching. Innovation is the name of the game. Who will lead the micro-drone revolution? Only time will tell. Building a mosquito-sized robot is a massive engineering challenge. Power is a huge problem. Normal batteries are too big and heavy. Scientists are developing micro-batteries and even exploring solar cells built into the drone's body. The brain of the robot, a tiny, energy-efficient computer, must control flight, process sensor data, and communicate, all while using almost no power. Miniaturizing cameras and microphones is another hurdle. Engineers are creating camera-on-a-chip technology to fit everything into a tiny package. Manufacturing is like building a ship in a bottle. Most assembly happens under a microscope, using techniques from chip making and 3D microprinting. Every part must be feather-light and precisely made. Solving these puzzles is what makes micro-robotics so groundbreaking. It's not just about shrinking parts, it's about reinventing how robots are built. The result: machines that are small, smart, and ready for the future. The engineering journey is just beginning. Micro-drones aren't just for the military. They could do a world of good. In search and rescue, they can fly through rubble to find survivors, saving lives and keeping rescuers safe. Scientists could use them to monitor rainforests, coral reefs, or even pollinate crops where bees are disappearing. In medicine, the same miniaturization could lead to tiny robots that deliver drugs or repair tissue inside the body. The technology behind micro-drones is a stepping stone to future medical breakthroughs. Even in daily life, micro-drones could inspect bridges, pipes, or help filmmakers get impossible shots. They could become new tools, toys, or hobbies. The key is that this technology is a tool. How we use it is up to us. With care, these tiny robots could help build a safer, healthier world. The potential for good is enormous. We just have to use it wisely. Micro-drones are more than machines. They're helpers for the future. The possibilities are inspiring. Despite their promise, micro-drones face big challenges. Power is still the biggest hurdle. Most can only fly for a few minutes. Payload is limited. Every milligram counts, so cameras and sensors must be tiny and lightweight. Control is tricky. Wind can toss them around, and skilled operators are often needed. The goal is true autonomy, but that requires smarter software and better onboard computers. Communication is tough. Tiny antennas mean short range. Durability is another issue. These robots are delicate and sensitive to weather. Making them tough and affordable is a major engineering task. Scientists are working hard, but there's a long way to go before swarms of mosquito drones are common. The hurdles are real, but so is the progress. Every breakthrough brings us closer. The future is challenging, but bright. Micro-drones are on their way. The mosquito drone is just the beginning. The next step: smarter, more cooperative robots. Future micro-drones will use AI to fly themselves, navigate obstacles, and make decisions. Swarm intelligence is coming. Hundreds of drones working together, inspired by bees and birds. Each drone will have a role, from surveillance to carrying tiny payloads or exploring underwater. New materials and sensors will make them even more insect-like, with artificial muscles and the ability to sense chemicals or pressure. The ultimate goal: artificial insects almost indistinguishable from the real thing. This isn't science fiction, it's the next frontier. The pace of progress is rapid. Micro-drones will keep getting smarter, smaller, and more capable. The future is full of possibilities. We're just getting started. Tiny flying robots are about to change our world. China's mosquito drone and others like it mark a shift in robotics. Machines are getting smaller, smarter, and more useful. These micro-drones could save lives, protect the environment, and revolutionize medicine. They'll make dangerous jobs safer and let us explore places we never could before. But with new power comes new responsibility. The same technology that helps can also invade privacy or be misused. We need to set rules and use these tools wisely. Technology isn't good or bad. It's how we use it that matters. The mosquito drone story is about curiosity, ingenuity, and learning from nature. We're at a turning point in technology. The choices we make now will shape tomorrow's world. The age of micro-robotics is here. The journey is just